Good afternoon, and this is my research on a new science discovery. I researched about the plastic-eating bacteria. European researchers identified a new bacterium that feeds on polyurethane, a kind of plastic that is difficult to recycle or destroy. The team from Germany's Helmholtz Center for Environmental Research said the discovery could help reduce the flood of hard-to-recycle plastics, filling up the world's landfills and polluting oceans. Many polyurethane-based products can release dangerous chemicals into the environment, but the research found the bacterium can produce enzymes that break down the material. A super enzyme degrades plastic bottles 6 times faster than before has been created by scientists and could be used for recycling within a year or two. The super enzyme derived from bacteria that naturally evolved the ability to eat plastic enables the full recycling of the bottles. Scientists believed combining these enzymes that break down cotton could also allow mixed fabric clothing to be recycled. Today, millions of tons of such clothing is either dumped in landfill or incinerated. Plastic pollution has contaminated the whole planet from the Arctic to the deepest oceans, and people are now known to consume and breathe microplastic particles. It is currently very difficult to break down plastic bottles into their chemical constituent in order to make new ones from old, meaning more new plastic is being created from oil each year. The super enzyme was engineered by linking two separate enzymes, both of which were found in a plastic-eating bug discovered at a Japanese white site in 2016. The researchers revealed an engineered version of the fast enzyme in 2018, which started breaking down the plastic in a few days, but the super enzyme gets to work 6 times faster. When we linked the enzymes, rather unexpectedly, we got a dramatic increase in activity, said Professor John McKeegan at the University of Portsmouth, United Kingdom. This is a trajectory towards trying to make faster enzymes that are more industrially relevant, but it's also one of those stories about learning from nature and then bringing it to the lab. French company Carbios revealed a different enzyme in April, originally discovered in a compost heap of leaves, that degrades 90% of plastic bottles within 10 hours, but requires heating above 70 Celsius. The new super enzyme works at room temperature, and McKeegan said combining different approaches could speed progress towards commercial use. If we can make better, faster enzymes by linking them together and provide them to companies like Carbios and working partnerships, we could start doing this within the next year or two, said McKeegan. In 2018, had determined that the structure of one enzyme called PETase can attack the hard crystalline surface of plastic bottles. They found by accident that one mutant version worked 20% faster. The new study analyzed a second enzyme also found in Japanese bacteria that doubles the spread of the breakdown of the chemical groups liberated by the first enzyme. Bacteria that breaks down natural polymers like cellulose have evolved this twin approach over millions of years. The scientists started disconnecting the two enzymes together It might increase the speed of degradation and enable them to work more closely together. The linked superenzyme would be impossible for a bacterium to create as the molecule would be too large, so the scientists connected the two enzymes in the laboratory and saw a further tripling of the speed. Team is now examining how the enzymes can be tweaked to make them work even faster still. There's huge potential, said McKeegan. We've got several hundreds in the lab that we're currently sticking together. A €1 million testing center is now being built in Portsmouth, and Carbios is currently building in the city of Lyon. Combining the plastic-eating enzymes with existing ones that break down natural fibers could allow mixed materials to be fully recycled, said the Professor McKeegan. Mixed fabrics of polyester and cotton are really tricky to recycle. We've been speaking to some of the big fashion industries, such as Zara and H&M, that produce these textiles because they're really struggling at the moment. Campaigners say reducing the use of plastic is key. Those working on recycling say that strong, lightweight materials like plastic are very useful, and that true recycling is part of the solution to the pollution problem. Researchers have also been successful in finding bugs that eat other plastic, such as polyurethane, which is widely used to rarely recycled. When polyurethane breaks down, it can release toxic chemicals that would kill most bacteria, but the bug identified actually uses the material as food to power the process. Even if these new technologies are one day deployed at a scale, they would still face major limitations and could even be dangerous, experts caution. Of the 7 major commercial types of plastic, the plastic-eating enzyme of the heart of several of the recent breakthroughs has only been shown to digest one, the PET. Other plastics such as HDPE, used to make harder materials such as shampoo bottles or pipes, could prove to be more difficult to biodegrade using bacteria. Nor are the bacteria able to degrade the plastic all the way back into a core elemental building blocks including carbon and hydrogen. Instead, they typically break up the polymers out of which plastics are composed back into monomers, which are often useful only to create more plastics. The Carbios facility, for example, is intended only to convert PET plastics back into feedstock for the creation of more plastics. Even if one day it becomes possible to mass produce bacteria that can be sprayed onto piles of plastic waste, such an approach could be dangerous. Biodegrading the polymers that comprise plastic risk, releasing chemicals in additives that are normally stored up safely inside the undegraded plastic. Others point out that there are potentially unknown side effects of releasing genetically engineered microorganisms into nature, since most likely genetically engineered microorganisms would be needed. They cannot be released uncontrolled into the environment, said Wolfgang Zimmermann, a scientist at the University of Leipzig who studies biocatalysis. Similar issues constrain the potential use of nanomaterials. Nicole Crawford, a nanomaterialist scientist at Oxford University, said that the tiny scales involved in the nanotechnology mean that widespread use of new materials add to the problem in ways that could result in yet a greater challenge for humanity. The best way to beat the plastic waste crisis, experts say, is by switching to reusable alternatives, such as the not-plastic seaweed derived materials, ensuring that non-recyclable plastic waste end up in a landfill rather than the environment, and using biodegradable materials where possible. Judith Ennick, a former Regional Environmental Protection Agency (EPA) administrator at the Obama administration and the president of Beyond Plastics, a nonprofit based in Vermont, pointed to the gradual spread of bans on a single use of plastics around the world, from India to China, from the continent of Europe to the UK, and a number of US states from New York to California. These are signs of progress, she said. Although more and tougher policies are needed, we can't wait for a big breakthrough. Thank you for your attention. And this was my report on new science discoveries.